All right, so in this video, I'll be talking through page 2 of the notes packet. And this is just where we're kind of zooming out and we're talking about what does it mean to actually solve an equation. So to solve an equation means that we find a value that makes both sides of the equal sign the same or equal. So for example, if we have this equation here, right, 3x plus 2 is equal to 5x minus 6. And we say, well, is x equal 4 a solution? Well, let's see. So if we do 3 over 4 plus 2, or sorry, 3 times 4 plus 2 is equal to 5 times 4 minus 6. We get 12 plus 2 is equal to 20 minus 6. 12 plus 2 is 14. 20 minus 6 is also 14. So yep, so there's a solution because it makes both sides equal. And kind of over here, we can see that x equals 2 is not a solution, because if we try and do the same thing, 3 times 2 plus 2 is equal to 5 times 2 minus 6. We get 6 plus 2 is equal to 10 minus 6. 8 equals 4, except for that it doesn't. So that is not a solution. And what we're going to be doing in this unit is, well, so this is how we think about how do we find a solution for a single equation. Now we're going to be looking at a system of equations. So we're going to have multiple equations with multiple variables, and we're going to need to solve all of the equations at the same time, right? We want to find one set of values, x and y, that solve multiple equations at the same time. So I have an example of one pair that does solve this equation, and then one pair that does not solve this equation over here. And let's explore that. So this one over here, we have the pair xy is 2, 5. So we're going to plug that in first to the first equation. We get 2 times 2 plus 3 times 5 is equal to 19. We get 4 plus 15 is equal to 19, which it does. So we solve the first equation. Plugging in the same values, we get 3 times 2 minus 4 times 5 is equal to negative 14. We get 6 minus 20 is equal to negative 14, which it does, so we've solved the second equation. So this pair 2, 5 is a solution to this system of linear equations. But if we look on this side over here, 1, 2 is not a solution to this system, and let's explore that. So if we do 2 times 1, right, plugging into our first equation, 2 times 1 plus 3 times 2 is equal to 8. 2 plus 6 is equal to 8. Well, that's fine. So we've solved the first equation. But if we look at the second one, 3 times 1 plus 4 times 2 is equal to negative 20. 3 plus 8 is equal to negative 20. 11 is equal to negative 20, but it is not. So we did not solve the second equation. So only this pair here would be said to solve this system. And a little bonus note here is in this class, we're just worried about two-dimensional systems, meaning that we have two equations and we have two variables. However, as you go on in math, you're going to generalize this. And you're going to say, well, what if we have 3 equations relating 3 variables, x, y, and z? Or you can even go all the way up and you can say, let's have 1,000 variables and 1,000 equations that relate them all. And as long as they are linear equations, the math for that is very tractable, right? You can actually solve an arbitrary dimensional system in a very logical and straightforward way.